Good morning or good afternoon, depending on where you are located right now. The purpose of today's meeting is to introduce you to our studio. For some of you, it's going to be new. For some of you, it's going to be review, depending on your experience level. But we're going to start from the beginning, don't worry. I'm recording this meeting for people who may not have been able to join us, and I'm about to get started. I'm going to share my screen, but before we do that, let's make a deal. When you're not speaking, you're going to mute your microphone, okay? So now let me click on share my screen. There we go, and oh, okay, another thing here is that, guys, please do not grab the control, okay? Only I'm a presenter. Please try not to grab the little ball over there. Okay, so let me go back and let me hit share my screen. There we go. So now here it is. This is our studio, and let me close this. So when you first install it, this is what's going to happen. You have 3 panels. The first panel is a console. That's where you type your code at the prompt. Right, you type your commands and all the output and error messages are going to show in this panel. Here you have an environment that's going to show you the variables or anything else that you have currently loaded in memory. We've got the history tab. Whenever you run the command, the entry is going to go to the history. Okay. So guys, do me a favor, if you're not speaking, please place yourself on mute, okay? That way we're going to have a good recording and productive session. Okay, so I was doing something in here, and any command that I run, it's going to go to the history log, okay? So now let me go back to the environment tab. Here I have files tab, and it's going to show me my files in the current working directory. Working directory is a folder where anything that I write is going to be written to by default, right? Or whenever I try to open a file, my R is first going to look into that folder. It's first going to look in an attempt to open the file in a folder that I set as working directory. Plus, here, right now it's empty, but this is where my visualizations are going to be like. Here, packages tab. All functions that are built in R are organized into the sets. And a set of functions is called a package. There are 2 types of packages here. There's the system library. This piece right here, everything comes with the installation. And there is a user library. User library are packages that do not come with an installation, but you are going to install them, okay? For some methods that we're going to use, you're going to install the packages, and I'm going to show you how to do that. So, help is a tab where the help page is displayed. Very often when I'm not quite sure what the command does or what parameters the command takes, I can run the help for that command to display the help page. Like, for example, suppose that I tell you to run the head command and you have no idea what it is. So what I'm going to do is I'm going to go in here to my console. I'm going to type. There is more than one way to display the help page. I can type a question mark, and I'm going to type summary. Right? So what that will do is, again, I have to hit enter. It's going to show me here the help page for the summary command. It gives me the command description and where would I use the command and the details and examples, right? So basically that's what it is. Now, data. You can load data to RStudio in a variety of formats. We have some data sets that come in with RStudio installation, such as Iris dataset. But sometimes if I want to use the data that's not part of my collection, right, I have to load the data set. I have to load the data set into the memory, right? And the data loaded into memory in an object called data frame, and we're gonna get to it. But first, let me show you more about the command. Okay, so I can use my RStudio as a calculator, for instance. Guys, if you're not speaking, do me a favor, please mute yourself. Or I have to stop sharing and mute everybody. I have to mute everybody now. Okay, now I have to share again. There we go. Now, here it is. I can use it as a calculator. For example, 2 plus 2 equals 4, something like that. I can also create, this is very important, creating a list, right? So I can just list my entries, red, blue, green, right? So what will that do? It will create a list. This is important because you'll see where it's used. When you do the plots, if you want to add color, you need to create a list, right? So this is just basic data structure. I can do my mass, I can add a list. So now we're gonna work with data, right? That's what most of you will do in the class. To load the data, there is more than one way. You can just type the command to do that, or you can use the tools menu. But before we even do that, we need to set the working directory. There is also more than one way to set the working directory. So the way I'm going to do this, I'm going to go session, and I'm going to go set working directory, and I'm going to go here, choose the directory. And what I did was I created the folder on my external hard drive. I created the folder and I call it data sets right here. And what I'm going to do is I'm going to select this folder, and that folder is a working directory. Now notice that what R does, it runs this command for me, right? It runs the following setwd command for me. Also note that your working directory is going to be displayed on the title bar of the console tab, right? So that's one way to do it, or I can just type the command. Either way. Now, most of the homework assignments you might not be able to do in one sitting. So what you're going to do is you can save the commands in a script file. So when you log back in to continue your work, you can just rerun the commands from the script. To do that, you go File, New File, and here I'm going to say RScript. So this is nothing but the file with an extension .r. Okay? So what you could do, okay, this is my first command that I ran, and I figure out the command worked. I want to save it to the file. I can do this. I can do copy and paste. Right? I can do that. Or instead, what I could do is I could go to my history tab. Watch. I can scroll down to my command right here, and I can hit to source. This will copy the command to the file. Now, what I could also do right now is I have to save it. I go File, and I select Save As. Notice what happens? By default, it opened the folders that I set as my working directory. And I can just save it as R practice, for instance. Or I already have a file with this name, so I would have to rename it, something like that, right? So let me close this out. What I did before this session is I prepared the script to save the time on typing. And how do I open the files that I already created? I go File, I go Open File. By default, it goes to my working directory, but I know that I saved my file at a different location. So I'm going to go ahead and I'm going to find my file and I'm going to open it. So I remember where I saved it, and this is right here, Introduction to R. .r. Notice the extension is .r. So here is the file, and after this session, I will go ahead and I'll post this script in the classroom. Now, what you could do is to run one command at a time. You position the cursor and you hit run. You can do that, or you can also, to run the whole script, you can do this Control A to select everything and hit run. You can do that, but we're not going to do it in a minute. I'm going to show you. So what we did here, I showed you that we can use R as a calculator. Here I showed you that we can create two vectors, and here is a command to set the working directory. Now what we're going to do is I'm going to show you how to read data from the file. Here it is, Tools, Import Data Set from Local File. Now, very important, I forgot to mention it, make sure that you install the latest R version 3.3, because some exercises that we're going to do in class may not work on an older version of R. So here it is. So I select from local file, right? In general, you can load the data from URL, but we're not going to do it at the moment. Okay, from local file. What does it do is, remember, this is my working directory, and now I have to find my, I need to find my file right here. Import, I'm going to hit open. What is this? This is a data frame name. Data frame is an object where my data get loaded to. By default, it's gonna pick up the file name, right? Import 85. I'm gonna delete the 85 just for simplicity. So this is going to be the name of an object where the data is going to be loaded to. Here is a preview. This is what I have inside my data file. The first row is a heading, right? Symbol, normalized losses, make, fuel. Obviously, this data set is about cars. Here is a preview of an object. Now, notice that NA stands for the missing values. What does it mean? If the value is not available, it's a little bit similar to, if you're a database person, it's a little bit similar to null. Okay, so now here, this is important because I want to keep my headings. It means that my first row right here are my headings. I want to keep them because if I select no, R is going to make the columns for me, name the columns for me. The names are not descriptive, but it's going to read the first row as the data. So I want to hit yes. Row names automatic, because I don't have anything in here that explicitly names the rows. Comma. What does that mean is that my values are separated by comma. And notice that I have comma, comma, and nothing in between. That's where it's reading the missing values. Okay. String as factor. What does that mean is that, see this, what make variable? Right, the values are the character values, and I want to read them as factor. Factor is a categorical variable. That's a terminology. You will see this interchangeably. The book may call it the categorical variable, and R calls it factor variable. Okay. Now what I'll do is I'm gonna hit import here. Let's see what happens. R is gonna run this command on my behalf. Import read.csv, and here this is a location, this is a path of the files. It's stored in the datasets folder in my E drive. That's my external hard drive. Obviously on your PC it's going to be a different folder. Now what it's also doing for me is it's running this view command. View command is going to open the file in a tabular preview, okay? Like this, right here. So what it does is the first row rather, are my column headings. Here, it's showing me the number of observations in a data set. In this case, I have 205. And here, it means that I'm previewing the first 7 rows, I think, right here. I can scroll down to see more rows. Now, another thing to keep in mind is that the element numbering starts from 1, right? And so if you are a programmer, if you're familiar with some programming languages, some languages start numbering from 0, but R start numbering from 1. Here it is, and A means missing value, and so on, right? What I could also do is I can click here, and it's gonna sort the column. But this is only gonna sort the preview, right? It's not sorting it in the memory. It's only sorting it in this preview. Okay, so right now my data set is loaded into memory. Whenever I make changes, I'm not changing the actual data on my hard drive. This is important. I'm changing only the data stored into memory. Another thing to pay attention to is right here. It's in environment tab. Right now it's no longer empty. I have an import data set loaded. Here it's showing me the number of observations and number of variables. See this? So what I could do is I can click here to expand this, and it's going to show me the list of variables right here and the variable data type, right? So for instance, symbolin is an integer, and in this data set, symbolin stands for the car race car. Now this is a car make, and so on. Factor. What factor is, it's a categorical variable, and the number of valid values is known ahead of time. Each valid value is called level. So this is a terminology, level. The way it's shown here is that it shows me my list of valid values. Of course, here I see the partial list, and here is a preview of the first few observations. So what 1 stands for is that my first data row has a make Alfa Romero. My first data row, if I scroll down, actually I'm not going to see it right in here because I sorted my data. That's a reason. Okay, so I unsorted, and look at it here. This is what it means here. 1, it stands for Alfa Romero, right? This is the first level. 1 means my first data row has Alfa Romero value, right? My first 3 rather. My next one is 2. So what's the second level? It's probably going to be Audi, right? So that's what it basically does. It's showing me the number of values, right, and the level. NA again stands for missing values. I'm emphasizing it, and I'm going to show you how to handle missing values as well. So now remember this. This is a data structure, right? Okay. Guys, can you may I please ask you again to mute yourself? Please hit mute. Guys, please put yourself on mute. This is very important because we want to have a good quality recording. Okay? Participants. When you're not speaking, you should be on mute. Okay, I'm gonna mute you right here. Okay. Now, what we're gonna do is I'm gonna go back to my scripts right here, just to save time on typing, right? See this here, view import. This is the same command that R ran for us in here. An alternative way to preview data is to run the head command. Now remember, head will display the first data rows. Default is 6. Excuse me? Guys, could you please mute yourself? Okay. Guys, if you're not speaking, you need to be on mute, okay? Now, okay, what we're gonna do here is I'm gonna put my cursor and I'm gonna hit run. what it will do is it will show the first 6 data rows. Okay? I'm gonna have to mute you physically. Okay, so now, since my data set has a lot of variables, all variables do not fit on a single line. What R will do for me is it's going to wrap, right? So that's why you see it wrapped around. Suppose that I don't want to see all 6 rows. I want to see only 3 rows. So I'm going to specify 3. Now remember, the head function takes 2 input parameters: the data frame name and the number of data rows to display.
It's fine.
Guys, if you don't have a question, please put yourself on mute. Okay? Now, here it is. And the less time I need to remind about putting yourself on mute, the more we're gonna cover in this session. Okay, now, to see the last rows, we're gonna run the tail command. There we go. And by default, it's gonna show me the last 6 rows, and I also can change it, and I can change it to last 3 rows. Okay. Now, what else I could do is I can display the dimensions of my data set, of my data frame, and I run the dim command to do that. So here it shows me the number of observations, and here is the number of variables. What I could also do is I can show just the number of rows, and to do that I just run nrow command, right? Okay, what else is here? Secretly, this is an array, right? What the output here, it shows 2 elements. And to show the number of rows, I can only show the first element of an output. So that's another way to show the number of data rows. I can only display the first dimension of the output, right? So we have the second dimension is the number of columns. There is more than one way. I can do ncol command, or I can do second dimension, or I can also do the length. Okay. Now, here, if you may remember, here I'm seeing the data set structure, right? An alternative way to do that is to run the str command. Here it is. This showing me the data set structure, which is my variables, variable data type. Here is the levels, right? And the preview, right? So here it means that my first observation has DOHC value. The second observation has also DOHC, right? The third observation has whatever the 6th level is, and so on. But this is a partial list. If I'm interested to see all levels, I can just run the levels command, which I'll show you shortly. Now, what you could also do is you can just display the variable names. Names command is going to show you the variable names, right? It's going to list them right here in each name is listed in a quote. Now, very important, you're going to like this command, the summary. Summary command is going to show you the descriptive statistics for your variables in the data set. Very important, note the difference between str and summary. Summary command shows you the statistics, while str command shows you the structure, such as data types and so on, and the number of observations, number of variables. Here, I see the list of variables, and for each variable, I see the statistics. So, width is a numeric variable. Numeric means it's a continuous number. We do not have a set of predefined valid values, like we do for the symboling, for instance, right? The statistics are the minimum, maximum, mean, median, first quartile, and the third quartile, right? Also, it's going to show me if I have the missing values and the number of observations missing a value for that variable, right? Missing value, again, is something similar to null if you're a database person. It means that the value is just not there, not available. Or, for instance, if it's a survey, sometimes the person who completes a survey could have left the field blank. Okay, so here also we have 4 missing values. What this one is, number of cylinders, this is a factor variable. And here it shows me the list of values and the number of observations that has each value. And if I were to interpret the results, I would say that the dominant number of cylinders is 4, the most dominant. And I have 159 cars with 4 cylinders. And here I have only one car with a 3-cylinder and only one car with 12 cylinders. So the least dominant cars have 3 and 12, right? Those are my least dominant values. This is what I would do if I were to interpret the results. Now, here, notice that the fuel system, what is others? Okay, what it does here is that it shows me 6 most dominant values. It shows me the count for the 6 most dominant values. The remaining values, it's going to group them under others category. So others means is the least dominant, right? The remaining values. That's what it's going to do here, right? So we know now, I'm going to assume that we know the summary command. So this is one way to do this. Another way to display the summary is to run the lapply function. What lapply does is it applies the specified function to all variables in the data frame. It's going to loop through all variables in the data frame. And again, what's a data frame? Do you remember? It's an object where we loaded data from the data file, right? Each column corresponds to the column that I had in my Excel file, or rather the CSV file. First row was the variable names, and this is data, right? So what it's going to do is it's going to loop through every single variable, and it's going to display the summary for each variable. Let me hit run over here. So this is one way, but it just gives me slightly different display. So which way I do it? It depends on the situation. There is more than one way. Okay. Oh, and here is a difference. Look at it for the make variable. Instead of just seeing the six most dominant values and grouping the remaining values under other category, I'm going to see them all. I'm going to see the counts for all values, right? So this is one difference. When I do lapply, it shows me more information. Now, suppose that my data set has 200 variables, and I want to see the descriptive statistics only for the price. Do I want to scroll through the list of 200? Do I really want to scroll all this long output? Of course not. So here it is. What I can do is I can specify the variable that I want to look at. And to do that, the summary command, okay, let me hit run. What I did was to specify the variable as an input, you put the data frame name followed by the $sign, and after the $sign we specify the variable name. Very important, R is case sensitive. Okay, so if in my data frame right here, price, note that the first letter is uppercase, right? I have to spell it the same way. If I do this, if I spell lowercase, I'm going to get an error. I'll show you. Now, let me show you something else. Suppose that I'm lazy to type. What I can do is I can hit upper arrow. Upper arrow on the keyboard is going to bring the command that I just ran. So, one way to do it is to hit upper arrow. right? Or you can also go to history and you can highlight the command and you're gonna hit to console. So the reason I'm doing it is because I want to show you what's gonna happen. I'm gonna delete P. I'm gonna do this. I'm gonna make an error on purpose right now. No. Why? Because it does not know what lowercase price is. Because there is no such a variable. It knows about price, uppercase. Right? So if you made this mistake, you can do, to find the correct variable name, you can do the summary, you can do the view, or you can do the head command, right? Because the head command shows the first 6 rows by default, and it also lists my variable names, right? And I can just copy and paste. Or the nice feature is here is, look, I'm gonna type the summary, right? And when I type I'm gonna type my variable here, see this? It gives me a hint, I would import. When I put the $sign here, it's gonna give me the drop down, and I can select it from the drop down. That's a nice thing also about R, right? So keep in mind that this is case sensitive. Now here I'm going to go back to my script. I can also display one statistics. For instance, I can show mean. I'm going to do run. Now, another thing to keep in mind is the summary command does not show all statistics that I might be looking at. For instance, I could look at standard deviation, or I can look at range. Range command is going to show me the minimum value, and it's going to show me the maximum value. I'm going to do run. Okay, now, this showing me my minimum price, the lowest car price, and the highest car price. This is only for numeric variable. There is no range command for the factor variable, right? So we need to keep in mind the data types. Now here, this is levels command. As you may remember, the categorical variables right here, right? Levels are the valid values, the predefined values of the categorical variables. Here I only see the partial output, right? To see the full output, one way to do that was to run the summary command that I did. I ran the lapply function back up here, right? Lapply function is going to show me more detailed summary for all variables, right? It's in here. I'm going to put my cursor and I'm going to hit run. Notice that here? But the problem is, suppose that I have 200 variables, and in fact some data set do have a lot of variables. I don't want to scroll through, right? So what I'll do is I can write this. I can do this. Levels. Okay? Hopefully this makes sense so far. So if you have questions, just let me know. But right now we're just going over the basics because this is very important. You need to understand the basics in order to move forward, right? Okay, here it is. Now, we did levels. Right now, what we also could do is we can take the subsets. We can take the subset of the data frame. The way we do this, every element in the data frame is referenced by row number, column number. Isn't it nice? It's a little bit similar to the battleship game, right? Where you have the row number and a column number. And an intersection of the row number, column number is an element, right? So what you could do is you can select, for instance, earlier I will run the head command, right? To select the first 6 rows from the import dataset. Imports. Right? That's one way. You could also do the same thing as this. Imports, and I can just type my, here I put the row numbers, right? 6. Here I'm going to specify my variables. When the number is omitted, it means I want all. There we go. So here, remember, row numbers 1 through 6, and here I'm doing my variables, my column numbers. in order to display all columns, I just omit the number here. What's interesting is that I can specify the first 3 columns, for instance, right? Here you go. But what if I know my column name, but I don't know the position where the column is? Here it is, see this? I can specify the column name. Do you remember earlier I showed you the list? This is the list. See this? When I don't have the specific column position, I have to specify the list. Earlier we looked at the list of colors. Here is a list of column names. So let me run this right here. So what I'm doing here, I'm selecting the first 5 values of the price variable, right? The first 5 values of the price variable. Suppose that I want to see the horsepower and the price. What I do is I list them both right here, run, right? And here, obviously, I want to see the first 10. I want to see my first 10 variables and the first 5 data rows. So here it is, right? So now, very important is there is more than one way to do the same operations in R. So I'm confident that if I ask you to display the first 4 rows, for instance, I'm going to see different answers. Right? You can run a head command, or you can do what I just did here, 1 through 4, and then here is going to be blank, right? So here I'm going to put blank, and here I'm just going to do 1 through 4, right? Like this. And some of you are going to do head command, which is also right, or subset command. There's more than one way. So either way will count. Now here, this is a frequency count. This only for the factor variables. And I want to see how many cars I have of each field type. I'm going to do run. Here it is. So now remember here, data frame name, $, and a variable name. Variable name and are case sensitive. Function names are case sensitive. So table in the lowercase is not the same as table capitalized or table in uppercase. Okay? Here it is. Now I can do like little crosstalk if I put 2 variables. It's not that nice. It gives me the count for the fuel type within the fuel system. Right? Here it is. And this is important because sometimes I want to see my frequency counts. Sometimes I want to break them down into the categories and subcategories. Now this thing right here, table, is also used as an input to the pie chart. So what I could do is I can build my pie chart, and it takes the frequency table as an input. Pie chart. So each slice, basically the size of each slice represents the relative frequency, gas and diesel. And here is using the colors, default colors, right? So here is my first chart, and it's shown on the plots variable. What I could do is, and in fact for some of your plots you're going to hit on zoom, and it's going to open a new window, right? Sometimes the plot is going to show a little bit too small on a panel, on a plots panel, so you can do zoom. Or you can also save your plot to the file, either export, save as PDF, or copy to clipboard. See this? So for instance, if you want to put the picture in your homework assignment, so you can do this, and you can do copy plot, and then you go to the Word, and you're just going to paste it, right? I'm going to hit cancel right now. Now, what we'll do now is, earlier today, I pointed out the missing values, right? Why is it important? Take a look. I want my horsepower variable has missing values, and this is a numeric variable. I want to see the average. Let me show you what's going to happen right now. And hey, R cannot calculate this for me because I have missing values. What I can do here, I have several options. One option is to remove the data rows with missing values. Another option is to fill in the missing values. It's called an imputation, right? Or if I don't want to change my data set, there is an option right here. na.rm equals true. This is an optional parameter. If I specify this, my computation will ignore the missing values and will still give me the mean. It's going to give me the mean of all observations where horsepower is not missing. This is an optional parameter. The default value is false. Now here, one thing to keep in mind is uppercase T is the same as true. Right? I can do this. It's the same thing. Right? So let me do this. Let me save this for you. History. And I'm gonna go here. So I'm showing you once again how to save this. Oops. So I put my cursor where I want to place it in my file. I go in here and I'm gonna hit to source. Okay? Here I'm gonna do this. I'm gonna save this. Okay? Okay. Now here it is. And another thing I wanted to point out is that this hash indicates a comment. Comments describe what the code does, but it's a non-executable line of code. Why do I do that? Because suppose that tomorrow I want to give my script to anyone attending this meeting, for instance, Pius. I want to give him my script tomorrow, and I'm going to ask him to add something to it. What he will do is he's going to read the comments to see what I'm doing already in here, to understand what I'm doing, right? Without the comments, it would have taken him longer to figure out what I'm doing, right? Oops. What I did here, this will save the whole workspace. That's one thing to do. And here save is going to save the file, right? Okay, so what we'll do right now, I showed you why missing values are a problem, right? And here, I'm just ignoring this, right? This is an optional parameter. If it's not specified, it's going to take false by default, right? Now, here, this is going to show me how many cases I have without missing values. And this is a little bit complicated command, but I'm going to show you. I'm going to break it down in here. Here is a condition, right? Here is a condition here. I want to select rows where the values are not missing. Where the values, yeah, look at this, complete cases. What this will do, if I just run this by itself, complete cases, it's going to return the data rows that do not have missing. It's going to return me if the data row has a missing value, right? Complete case, okay, rather it's going to show true if it's going to show true when all variables have a value, right? It's going to show false if in that specific data row at least one variable is missing value, right? So complete cases, right? It's going to return for every single data row, it's going to return me if at least one variable has a missing value. What this is, it tells me that the first value is here for observation number 1, this is for observation number 15, this is for observation number 29, and so on, right? Okay, now, what I'm doing in here, if I do this part, note that I can do this. Now remember here, this is a subset, right? This is a subset. Here, exclamation point is an inverse, right? So here, if it's false, the exclamation point is going to turn it to true. I'm specifying here as a condition. I want to select only incomplete cases, right? I want to select only incomplete. Incomplete means I have at least one variable missing a value. Here, I don't have anything after comma. It means that I want to select all variables. There we go. It wraps it for me. Okay, but this is kind of hard to read, right? So what I could also do is I could nest it inside another command. Let me put head command. This is your friend, right? This is your friend because something like this is very difficult to read. So you want to see only the first 6 data rows. And see that if you notice it, every single data row has at least one missing variable, has at least one variable with missing a value rather, right? So now here, n row, do you remember from above? N row returns the number of rows. So here I'm nesting 3 commands, right? Here I'm selecting a subset, right? I'm selecting the subset of data rows missing a value. Here it is. Here, this is going to return me the number of incomplete cases, right? And here, it's going to do the number of complete cases. And you want to make sure that these 2 numbers add up to the number of cases in a data set, right? Because if I do this, n row, and here I put the data set name, import. There we go. So these 2 are supposed to add up, right? Now, here, what this does is NA is going to check if the value is missing, right? If NA is going to check if the value is missing. It's going to go through every single row for the horsepower variable. So let me hit run, see what happens. Here it is. So it's going to show me that the first observation is not missing a value for the horsepower rate. True, it means it's missing. And how do I get the observation number here? Look, the first starts from 127, 28, 129, 30, 31. This is 131. This one is missing a value, right? Now, what we can do is we can remove the cases that have missing values, but the problem is we may lose data, right? What if I have a variable where half of my cases are missing a value? I don't want to lose half of my data, right? Or I could also replace my missing values with the mean of a variable. This may or may not work because suppose that most of the instances are missing a value, right? Most of my observations or instances, you're going to see these terms interchangeably, are missing a value. Then it's going to create some bias, okay? So there is more than one way to handle missing values, and the way you do that depends on a study, depends on how many instances are missing a value. Sometimes you may need to remove the variable, okay? So, but here I'm going to show you how to replace the missing values with a mean. Now, here is an A. This will return if this returns if the observation is missing a value for this variable. Here, this is a conditional selection, remember? What I'm saying here is I'm gonna grab the indexes, I'm gonna grab this, right? Here is gonna grab the observations where the values are missing, right? Because this here is the conditional selection. The condition is whether this is true. I have 2 observations with this true, right? And here what I'm doing is that I'm computing the mean. I'm computing the mean of the horsepower variable. But now, do you remember why I'm doing this? Because I want to compute the mean ignoring the missing values. I want to ignore my missing values. Alright? So what I'll do is, I hit here, run. There we go. Now, how can I validate that the missing values are gone? There is more than one way. One way to do that is I can do my summary command, and I'm going to do summary imports, right? Imports, and then I'm going to put the $, and I'm going to select the horsepower. Or I can just type H here, and it's going to limit the list to variables that contain H's in the name. There we go. See, it's gone. NA is gone, so that's one way, right? There's more than one way to do this, but this is one way, okay? Here we go. Now what we're gonna do is we're gonna go to installing the packages. Remember, package is a functionality, right? Group of methods set of methods are grouped into packages. A lot of packages come with RStudio installation, but some of them are not. For example, if you want to run the association rule method, or if you want to run the discretization, which divides the numeric variables into bins, right, binning, you need to use a rule package, rules. But that package does not come with RStudio installation. So what you do is you do this: install packages, right? Install packages, and in here I'm gonna type my package name, rules, right? I'm gonna hit enter key. If you already had the package installed, it's just gonna reinstall it. Now, what it does is it installs the package on my local directory. There we go. This is a local folder on my hard drive. Depending on your operating system, when you install your very first package, you may get a prompt. It will ask you if you want to install the package in a local folder, because you cannot really install anything in a programs folder on your operating system. So what you're gonna do is you're gonna just select yes, and that's all. It will do it. Here it is. It's gonna create this folder, right? Very first time when you run the first package, when you install the first package for the first time, this folder is going to be created, and this is where the package is going to be stored, right? This file. Now, very often a package may depend on another package. There could be a function that depends on the existence of another function, and what R will do is most of the time it will install the dependency, and sometimes it's not. Sometimes it may give you an error message that something that the package depends on does not exist. So you would need to install the package on which this depends on, right? Another thing to keep in mind is that, okay, I installed my package, but it doesn't necessarily mean that I'm ready to use it. It's not in the memory. Every single time when I log in, when I open the RStudio, and if I need to use my package, I have to load it into memory. There is more than one way to do that. The simplest way is probably go to the Packages tab, find my package, and click this checkbox right here. There we go. Okay, it will do it. Secretly, this is going to run this command on my behalf. Here you're going to see something in red, but it's not an error message, it's just an information message. It does not say an error, so we're good to go. And also notice this package right here is checked, right? So we are good. And right now we are ready to run the discretization, but what is this? It's gonna convert my numeric variables into bins. Like, for example, suppose that I'm not interested in a specific value for the horsepower. I'm interested in a range, right? Probably easier example is going to be your test grade. A, B, C, D, right? So those are the bins. A, B, C, D. Or you can look at the specific grade numbers, but when you look at your academic record, there is no grade number. There is no, it does not matter if you got 90% or if you got 95% course average, you still got an A, right? So that's what discretization is. And we do it because some methods that we're going to use, they don't run on numeric variables. You have to do the binning. And there are several types of binning, as you would see later on if you're in DBST 667. It's the topic of second week topic. We're going to do the discretization. There are several methods. One method is interval. I want to split my values into approximately equal intervals, right? In the grade example, that would have been, I want to make 80 to 100 is an A, 60 to 79 is a B, and so on, right? Here, engine size, I want to split into perhaps 5 categories. I need to specify the number of categories. This is variable name, and this is a method, binning method that I want to use. There is an equal width, right, or interval. There is an equal frequency. Perhaps the first, I want to be the first top 5 in the first category, next 5 in another category. This is the equal frequency, right? And I can also specify the boundary ranges. So see this import I'm going to do, first I'm going to see what's going to happen. And in order to do this, I think it's better to show you like this, right? I'm going to hit save. So what I'm going to do here, I'm going to show you what I mean. I picked engine size here. So here it is. This is my engine size. It's a continuous number. And this is the statistics. So suppose that my method does not work for continuous variable. I can do this. I can run discretize. But there again, what it did was it put an output to the screen. It did not change my data frame in the memory. It did not do that, but I'm going to do that shortly. But what it did here, see this, the values are, right now the values are the ranges, right? Ranges. So this becomes the ordered categoric variable. It has an ordering. The curly brace means the boundary value is excluded, and a square means the boundary value is included. Now, what happens if I want here? What I would have to do is arrow right here is an assignment operator. What I'm doing here is I'm setting my engine size variable to the discrete values. This is an assignment, right? And this does the discretization, right? So now, how do I verify that it did what I wanted to do? I hit run. Oh, again, you're gonna think it's okay. See, notice that? Do you like this? It's an equal interval. Notice that right here in this interval I have only 3. Here I have only 4, right? Because it took the interval width. Here, see this? If I take the highest point minus lowest point, it's not going to be exactly, but this distances, the width of each interval is going to be approximately equal. It's not going to be quite equal, but approximately. On the other hand, let me take a look at this. This is a width variable. I'll do this right here. So what I'll do is I'll run this first, right? Width. And here I'm going to use the equal frequency. And I'm going to run the summary command. Notice that what it did, it put approximately the same number of instances in each interval. See this? So I have 42 cars with a width between 60 and 64, something like that, right? I have 43 cars in this range, and so on. That's my interpretation. If I were to interpret the results, I would say 42 cars have a width between 60.3 and 64, well, and so on. That's how I would interpret. And here it's just fixed. Fixed means that I can specify my boundary points, right? That's what it is. For the height, I want to specify my boundary points. I can explicitly do it, right? And again, there is more than one way to do discretization. If I'm not sure what this function does, I can always do this, right? Discretize, and it's going to show me the help page. Here we go, right? And again, the success in R, I think it's very important to read the help pages. This is your friend. Okay, here is a function name, and here what you see is the name of the package where the function is located. And here it's showing me what the function does, different input parameters, and there are some examples, of course. Now here it is, and this is another thing is the sorting. I showed you how to sort, let me say this. I showed you how to sort here, right? Just by clicking on arrows, but it doesn't actually sort the data in the memory. It only sorts the preview. If I want to sort this, I would have to put this in braces right here. Here, it's telling me that I want to select all data rows, but I want to select my rows sorted by the price, ascending, and all variables. See this? So what this part will do right here, this piece, is going to do this. It's going to grab all data rows right here, and the price is going to be sorted ascending, right? It's going to be sorted ascending. What I could also here, what I'm doing is I'm creating another data frame, and I call it import sorted, and I'm setting it equal to this guy right here, sorted price. There we go, run. And here I want to preview, right? And it's showing me that my data is ordered by price. And in order to sort descending, you're going to put the minus sign right here. Minus sign means that I want to sort descending. And this is very important because sorting enables you to see the top 5 values perhaps, or sometimes you can spot the duplicates, right? There are numerous reasons you want to do the sorting. So I go run. There we go, and I hit head. Okay, I think some of you might be wondering if it's possible to sort by more than one variable. Yes, it is. Here, the primary sort is by symboling, and if more than one cars have the same risk level, which is symboling, right, it's going to sort by price. Okay, hit run. And here I'm going to hit head just to preview. Okay, so if you notice that here it is, the first 3 cars have symboling risk level equals -2, and they displayed first, but they ordered by price, right? Okay. Another thing that I'm going to show you is a plot command. Plot command enables visualizing the data. So I'm going to hit run. There we go. This is a default plot, right? And if you run the help command, you're going to see various options. You can do the line chart, and you can do the bars chart, and so on. See this here? Points, lines, balls. Here, the stair rather, not bar. This is a stair, and no plotting. So here you have options. And you can also specify you can rename the y-axis, x-axis, and the main is going to put the title. So you can play around with this. And I already showed you the pie chart. This is the histogram. So what I did here was I put my variable, data frame name, $, variable name. Here I'm specifying the colors. Remember, this is an array of colors, and I can put single quotes or double quotes in this case. Now, oh, look at this. I have more bars than colors that are specified. It's gonna wrap. It's gonna repeat, right? What I could also do is I could add the title. There we go. Price distribution. And you can rename these labels here. So basically it's rather about reading the help. So help is your friend in here, right? Okay, so at this point I'm going to ask if you have questions. Questions? This is a perfect opportunity to ask questions. I covered a lot of topics today, but I want to make sure that this is really helpful to everybody. Yes. Anybody has question? Okay. Oh, how do you clear the workspace? Oh, there is more than one way. I believe it's this. Let me see. I'll have to look it up because there is more than one way to clear the workspace. You mean clear this area? Yeah. Let me see. Oh, here it is. This is what you can do. When you start the RStudio, let me start another instance, RStudio. Okay, see this? When I start again, it's gonna show me. This command is listed right here. Come on, come on, come on. Here it is. To clear the workspace, it's listed here. It used to be. Or there is actually another way. Let's see if we can do this through the menu. Let's see if we can do this. Let's see, tools. There should be somewhere in the menu. Yeah, there should be somewhere in the menu to clear the workspace. So it's oh, clear console. Here it is. Sorry, guys. Here it is. Clear console. This is how you do this to clear this console. Okay, but to clear the environment tab, what you can do is, see this, there is a broom right here. But this is very dangerous. The broom is gonna remove all objects that I currently have in a workspace, okay? This broom right here is gonna remove everything. This broom right here is gonna delete all my charts. This one is gonna delete those current charts. Did I answer your question? Did I answer the question? Excellent. Yes. The same request? Oh, you mean how to do this? You mean you had the same question about, yeah, okay. So see this? Edit, clear console. Edit, clear console. This is gonna clear this screen right here. Yeah. Sometimes you want to do this, trust me, sometimes you want to do this. But it does not clear the history, see? I can still do this, right? It does not clear the history. To clear the history, I have a broom here. Or to delete a specific command from the history, I select it and I click this. And then it's gonna give me the prompt. Yeah. Yes. The commands, yes, I'm gonna post this script. Definitely, this script will be posted in a classroom with the recording. I'll definitely do that. Yep. Here is a script, and it's gonna have the .r extension. What you're gonna do is you're gonna download it to your hard drive. You're gonna save it. And sure. And then what you're gonna do is you're gonna go here, File, Open File. You're gonna find a location where you saved your script, and you're gonna open it, right? That's how you're gonna do this, right? So if you are in a DBST 667 next week, there's going to be step-by-step tutorial. It's also on cars data, but it's a different data set. There are different cars data sets available. Okay? So just keep in mind it's a different data set. So what I'll do is I'll post the script and I post the copy of the data set that I'm using, because you may want to try to run the commands on your laptop and try to reproduce what I was doing here. And I think this is really helpful when you sit down after this session and try to reproduce what I did and perhaps add more to your notes, right? And let's see if we have more questions. I like questions. They're very helpful for everyone. Questions? So now if I ask you about the difference between the summary command and str, yeah. Huh? Let's speak up, because okay, I'll have to open the chat room now. Chat. Okay. Data frame is basically an object, okay? Data frame is an object where my data set gets loaded to. It's an object right here, right? And I can operate, this is sort of like a data set, where table is just a matrix. It's a different set of operations that I can do, right? This is basically it's an object. And I can, what I could also do is I could write it to the file, I can delete the variables, I can do more manipulation. The main difference is an operation that I can do. It's a grid, yes. Yes, you can. Oh, the head command is not gonna open it as a grid. The head command is not gonna open this in a grid. The view command is gonna do it. View open as a grid. Head does not. That's the difference. Head command is not gonna open it as a grid, right? Okay. The head command is gonna just preview in a textual format, right? The grid is a view. Head is a textual, so just something to keep in mind. And this is actually editable. Right? It opens another window right here. And I can change it, I can rename my variables, and so on. But the thing is, I would not recommend doing it this way, because if I make a mistake, really cannot undo. And also because what if my data set is huge? I'm not going to search through, right? I'm going to write the code instead. Let me close this out. Okay. Okay. So let me see. What other questions do we have? And again, keep in mind, the table is a different data structure, right? Different operations. Or the same command could be run on the same command could be run on different data structures, right? But the output is going to be different. And also, summary command is going to be very useful when you start building the model. Yeah. Plot command. Okay, sure. Let's repeat the plot command. What plot command does is it builds a nice, beautiful plot. So what I could do is, let me do this. And now I'm going to put my data frame name, right? Import. And now I'm going to select my variable, and I'm going to do just num of doors. Let's see what happens. There we go. What did it did here? Why did it put a bar chart? Because it's a categorical variable. Are smart, right? So basically, the plot command here just specifies a variable name. That's all. The rest of the parameters are optional, right? The rest of it are optional. I can specify the colors to show this bar in a different color. Or what I could also do is I could specify the title here. To specify the title is this main equals, and here I'm just gonna type the right. There we go. This is number of doors, right? And what I could also do is I can do this. I can navigate between my plots. Right? I can navigate, I can zoom, I can export, I can delete the specific plot right here. Or the broom will delete everything, right? And same thing in the help. I can navigate between pages if I got to show you that. Okay. So let me do this. Let me save this. Let me save this right here. Plot to source. Plot to source. And I'm gonna hit save here. Right? Or also I could do is I can specify my numeric variable price, right? Comma, imports, and here I'm gonna put the $sign, and here I'm gonna select something different. Let's see what happens. See this? Here instead of observation number, it put imports as an x-axis and the height as a y-axis. I can do that, right? Or I can do, let me try this. It's case sensitive, so here it is. It did the line plot, right? So let me put this right here too. To source, and this is L type. L is a line plot, right? Okay. So did it help? Did it help? Anything else? Great. Anyone else? So, another thing I wanted to point out in your classroom, there is a web page that I created, and so this is a DBST 667 classroom, but if you own in Data 650, you also have a similar page, but maybe slightly different resources. RStudio resources by topic. So what I would like you to do is, I would like you to go through these videos as many as you can, and you will find them very helpful with your assignments and so on. So like working with variables, and data pre-processing, data visualization, and so on. And in here, I put some useful tips that you have. This as an interactive tutorial where you can go through and you can actually practice type the commands as you go through tutorial. There are some cheat sheets, like for instance RStudio tips. It gives you some information on different options you have in the RStudio. And there is a short reference card that lists the commands, some important commands in R, right? So this is something that some people think is helpful to print out and have it in front of them as you're working on assignments. See this? And there is more than one way to run a help command, for instance, right? So you're gonna find this useful. Let me go back here, and there are some booklets. They're available for free. Some how-to guides are for beginners, and then there is a question and answer site, and so on. So you're gonna like these resources, right? And another thing to point out, this is what you're gonna do regularly, because RStudio keeps on updating. So perhaps once a week, do this, tools, check for package updates. Well, in my case, everything is up to date because I recently updated. But it's going to give you a list of packages that need updates, so you just select them and hit update. Do this, okay? You want to have the latest version at all times. Yeah. Have the latest version at all times. Alright? Because sometimes when you attempt to install a new package, it's going to grab the latest version by default. But the problem is we have dependencies, right? So if the R picks up the new package that you're trying to install, right, and you have the old version of the package on which the new package depends on, there could be some problems, right? If your current R version perhaps does not support the new version of the package, there are going to be problems. So you want to make sure you want to keep the packages updated and you want to keep the R version updated. Hopefully during the semester there is not going to be a need to update the R version, but you still need to update the packages. This R version was released in early May. So what I did was I went ahead and updated the exercise instructions to make sure that we have the latest and greatest commands and so on. Yeah. So let's see, questions? Questions? Some of you may have met me in earlier courses and you know that I like questions. Any questions? So everybody is going to be an R expert now? Say yes. Alright, if there are no questions, then I'm going to stop the recording and everybody enjoy the rest of the day.